Hello and welcome to Coffee Coder. My name is Andrew, and today I will be talking about arrays within the C++ standard template library. In this video, I will be explaining what exactly an array is and show you how to use one in C++. So let's get started. Arrays are a type of sequential container, meaning items within this container are referenced by a position rather than a key. An array, in particular, is a fixed size sequence container. For example, here we have an array of 5 items. In this case, our items happen to be characters. Our array size is fixed, so if we wanted to add another item, we would have to create a new array. To reference an item within our array, we use integers to point to their position. Notice that in C++, it is common practice to reference the first item as in position 0. So the last item will be in position n, being the size of the array, minus 1. Arrays can be useful to solve simple computations that have a list of values for a fixed size. Okay, so let's head on over to our text editor and write some C++ code. Arrays are included in C++ by default, although if you wanted to, you could use the array class by typing in #include array. This class adds a layer of member and global functions to a basic array. For example, when you define an array, you will have to manually keep track of its size, but using this array class, you can use the .size function to get its size. For the purpose of this video, I will only be going over traditional arrays, not the array class. So arrays are included in C++ by default, so you'll not have to include anything in your CPP file. There are quite a few ways of defining an array. One is to type out the data type, followed by the name. Then in square brackets, we type the integer that will define our size. If we stop here, the contents of our array will be random. We could also define our values when we define our array by using the equal operator, followed by curly brackets. And in the curly brackets, we type out the values that we want to store in our array. We could, since we are defining the values in our array, remove the integer, and our definition will recognize that it is of size 5 by how many items we pass in our array. Also, we don't necessarily need to use the equal operator. This will work too, but adding the equal operator is good practice. We can access values within our array by location, which makes looping through arrays very easy as we start at 0 in a for loop. And we loop until we reach the size of our array, which in our case is 5. And we just increment the integer and reference the location within our array. So as you can see, we made a for loop that prints out each item as it comes across it, 36832, in our array. So one interesting to note about arrays is that the name of the array is a pointer to the first element within that array. A pointer is a variable that holds the memory address of where a value lives in memory. When we create a function that has a parameter with ampersand in its definition, like so, it is passing this value by reference as opposed to sending a copy of this data to the function. For example, let's say we have an int x, or an int temp, and we set it equal to, let's say, 2. And then we call upon our function, and we pass in our temp variable. And normally, if we didn't have this ampersand, a copy of whatever we throw into here as a parameter would be made, and any changes done in it, in this function, would stay in that function. But since we pass it by reference, this temp is being subject to change. And I'll demonstrate this. So after we create our temp and we pass it to the function, I will cout it. And then within our function, let's add 5 to our x, and then run our code. And as you can see, 5 was added to 2, and 7 was output. If we got rid of this ampersand here, the 2 would not be changed, and we would end up printing 2. And let's run our code. So 2 is printed out. So this is true for arrays, as arrays are in sense always being passed by reference. So any changes I do in a function to an array will affect the original array. So let me demonstrate that to you right now using the code we had previously written. So in this case, let's say I'll increment the first 3 by 1. And let's do a little before and after. So as you can see, we had 3, 6, 8, 3, 2, and then we passed it through this void function, which incremented the first 3 items. So now we have 4, 7, 9, 3, and 2. That is all for arrays. I hope this video was helpful and that you learned something. If you want to know more about arrays, I will paste a link in the description below to a C++ reference on arrays. And I hope you have a wonderful day, night, or whenever you're watching this.